penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi Guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih. Indah berbalam si awan petang, berarak jecelah pepohon ara. Pemanis kalam, selamat datang, awal bismillah, pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan selamat datang ke Pusat Tuisyen Online Percuma Akademi Youtuber Malaysia dengan kerjasama IDD Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Anda sedang menyaksikan kelas tuisyen online percuma bagi subjek Fizik SPM Tingkatan 4 dengan tajuknya 6.4 Thin Lens Formula kelas untuk DLP. Jadi sebelum kita mulakan kelas pada malam ini kepada yang beragama Islam, ayo kita mulakan dengan bacaan Ummul Kitab Al-Fatihah dan doa belajar, dan bagi yang bukan beragama Islam anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Jadi sekali lagi selamat datang kepada semua guru-guru dan anak-anak murid yang cikgu kasihi sekalian di mana jua anda berada. Cikgu doakan anda sentiasa berada dalam keadaan sihat walafiat. Okey, jadi pada malam ini insya-Allah cikgu akan sampaikan satu lagi tajuk, iaitu tajuk 6.4 Thin Lens Formula. Anda yang baru pertama kali menyaksikan kelas tuisyen online percuma ini, saya ialah Cikgu Hasnitah binti Andy Mario yang kini berkhidmat di SMK Bagan Jaya, Butterworth, Pulau Pinang. Di akhir siaran nanti, cikgu akan kongsikan pautan kepada e-sijil Express yang anda boleh tebus di hujung nanti. Isikan nama dan nombor kad pengenalan dan sijil akan dihantar secara automatik ke email yang anda gunakan. Anda boleh gunakan sebarang jenis email untuk mengisi sijil Express di akhir siri ini nanti. Okey, jadi anak-anak sekalian, kita tidak mahu melengahkan masa lagi. Jadi ayo kita bermula. Sebelum itu, boleh tak cikgu dapatkan sedikit respon? Kalau anda boleh dengar cikgu dengan jelas, boleh type nombor 1 tak dekat live chat. Okay, students, if you can hear me clearly, can you please give me a sign? Type number 1 in the live chat. Thank you very much for your response. Okay students, so this is our class this week. Minggu ini kita ada satu saja kelas fizik, iaitu kelas fizik tingkatan 4, tapi insya-Allah pada minggu hadapan kita akan ada 2 siri, iaitu untuk tingkatan 5 siri pecutan akhir SPM akan disampaikan oleh teacher Cikgu Rosemawati pada Jumaat 8.30 pada Jumaat 9.30 malam pada Jumaat minggu hadapan, iaitu pada 17 Oktober, dan pada 19 Oktober nanti akan bersama-sama saya lagi untuk tajuk yang kedua terakhir, iaitu 6.5 Optical Instruments. Okey, jadi ayo kita bermula. Sebelum tu cikgu nak kongsikan anda boleh dapatkan bahan PDF kopi kepada modul yang cikgu guna sepanjang kelas ini, di mana cikgu ada pinkan pada pin messages. Dia juga boleh didapati pada deskripsi video di bawah. Jadi anda boleh muat turun, boleh cetak keluar secara percuma saja sebagai panduan yang anda boleh gunakan bersama-sama dengan video pembelajaran ini. Alright students, Okay. So, cikgu perkenalkan dahulu, ini adalah ahli panitia fizik sukarelawan Akademi Youtuber yang ada bagi subjek fizik SPM. Cikgu-cikgu inilah yang telah banyak membantu saya untuk menghasilkan video-video PDPC sama ada untuk kelas DLP ataupun bukan kelas DLP dan juga mengendalikan tuition online secara percuma di Akademi Youtuber. Jadi di mana nak dapatkan video-video yang telah dihasilkan oleh cikgu-cikgu ni, anda boleh muat turun aplikasi Akademi Youtuber di Android anda. Kalau belum muat turun, boleh muat turun pada hari ini kerana kita ada lebih daripada 26,000 video PDPC daripada prasekolah hinggalah ke pra-universiti. Video-video ini telah dihasilkan oleh semua guru sukarelawan AYU daripada seluruh negara. Jadi harapan kami, moga video-video yang dihasilkan ini membantu anda dalam mengulang kaji mata pelajaran yang anda pelajari di sekolah. Okay. Selain daripada memuat turun aplikasi Akademi Youtuber, anda juga boleh dapati video ini di portal Akademi Youtuber www.akademiyoutuber.com. Alright, so without further ado, let us begin our lesson tonight. So, ada 6 orang bersama dengan cikgu pada malam ini. If you are new to this lesson, you can introduce yourself. Jangan malu, jangan segan. Kalau ada soalan nak tanya pun boleh ajukan di ruangan sembang. Alright, if you have any question, you may type your question in the live chat and you also can respond to the question in the exercise search part later on. Alright, students, so let us begin with our first learning standard. This is 6.4.1, an experiment to investigate the relationship between object distance u and image distance v for a convex lens, and second, to determine the focal length of a thin lens using lens formula. So, dalam standard pembelajaran yang pertama, kita akan lihat satu contoh eksperimen untuk mengkaji apa hubungan di antara jarak objek dan jarak image bagi kanta cembung. Dan kita juga akan menghitung panjang focal menggunakan formula kanta nipis iaitu 1/F sama dengan 1/U tambah dengan 1/V. Alright? Okay, so before we go to the experiment, let us take a look at this diagram first. So if you look at these two diagrams on the left and on the right, okay, what is the difference between these two diagrams? Apa beza gambar di sebelah kiri dan kanan? Yes, so this is the image for different object distance which is placed in front of a camera lens with the same focal length. Okay, so lensa kamera ini mempunyai panjang fokal yang sama. Apa yang membezakan? Objek diletak pada kedudukan yang berbeza. Objek diletak pada jarak yang berbeza di hadapan kanta. Okay, so the first image on the left, okay, the object is placed at the distance of 0.5 feet from the camera. Okay, and for the second diagram on the right, the object, which is the car or the toy car, is placed at a distance of 1 feet from the camera lens. So object distance on the right is longer compared to the object distance for the diagram on the left. Okay, so this camera has the same focal length of 24 millimeters. So what can we see here? When the object distance is shorter, it will produce larger image. Okay, for A, as the object distance is shorter, so it will produce larger image. Alright, okay. What about the second situation? Okay, situation B. Now what happens, students? Now the image, the object is at the same distance. Okay, the object, which is this house, is at the same distance in front of the camera, but now the camera has a different focal length. Okay, for the camera on the left, it has a focal length of 24 millimeter, and this is the size of the image produced, while the camera on the right side has a focal length of 60 millimeter, and you can see the image produced by the camera will be larger compared to the camera on the left. So here what we can say, when the object distance is the same, a short focal length produce smaller image. Okay, when the object distance is the same, a shorter focal length will produce smaller image. All right, so this is as for our introductions or induction set for thin lens formula. Okay, this is another few image you can see for same object distance which is taken with a camera lens of a different focal length. Okay, so we have 9 diagram over there. You can see this is the size of the image produced by a camera with a focal length of 14 millimeter. And this is the distance of the size of the image produced by a camera with a focal length of 400 millimeter. All right. Okay. Okay, so now let us take a look at the experiment, students, on how to determine the relationship between the object distance and the image distance of an object. All right. So our inference for these experiments, image distance influenced by object distance. So RV influenced by MV. Okay, so our manipulated variable is the object distance. Our responding variable is the image distance. So how to write hypothesis for this? So if you download my PDF copy, there is a blank spaces you need to fill up for inference hypothesis, variables and so on. All right, so don't forget to download them later on, and you can get the full answer back from this video. Okay, you can rewatch this video after the live end at any time you are free with. Okay, no problem. Okay, student, then for hypothesis. So how we write a hypothesis? So we can say when. Remember the format for hypothesis: when MV increases or decreases, then RV increases or decreases. So for this experiment, when the object distance increases, the image distance decreases. Okay, we write the hypothesis. So we know object distance is inversely proportional to object distance. Okay, and the aim for this experiment always begin with the word to investigate or to study the relationship between MV and RV. So we write to study the relationship between object distance and image distance. So this is helpful when you are dealing with your UAS later on. Okay, in some question, they ask you to write for inference. They maybe ask you to write for hypothesis, aim, and variables of this experiment. All right. And second, since we are conducting 2 experiments here, so the second is to determine focal length of a thin lens using the lens formula. All right. Okay. Now, our variables, student. So remember, in UAS, when you write your variables, you must write a physical quantity, especially for the constant variable. Okay, so our MV is object distance. Here we give a symbol to it, which is U. And our RV is image distance, which is V. So what is the constant variable? Is the focal length of the lenses. So you please don't write type of lenses. Okay, so because type of lenses is not physical quantity, so we write focal length as the constant variable. Okay, focal length F. Okay, and for the apparatus as given in diagram, you can see there is a convex lens. Here we are using convex lens with a focal length of 10 centimeter, a lens holder where we place the lens at, a bulb as our sources of light, a wooden block to support the bulb, and a widescreen to see where our image form at, and a meter rule to measure the object distance and image distance produced. All right. Okay, so this is the procedure you have to follow from number 1 up to number 4. We begin by preparing the apparatus and material as shown in diagram. Then we adjust the screen in order to form a sharp image on it once we switch on the bulb. Okay, and we measure the image distance, and we repeat this experiment with a different object distance of 30 cm, 25 cm, 30 cm, and 20, 25, 30, and 35 cm. All right. Okay, and student, this is the example of result we obtained from this experiment. So you can see when the object distance increases from 15 to 35, what happened to the image distance? It is decreases, okay, from 30 to 14 centimeter. Okay, and here is the reciprocal of u, and reciprocal of v we determine from calculator. So 1 over 15 is 0.06, 1 over 30 is 0.03. Okay, so when you are collecting and recording data, make sure they are in a consistent form, mean same decimal places. Okay, so this is our primary data determined from using meter rule. So how many decimal places? It is depend on the sensitivity of the instrument you are using. So as meter rule can measure up to 1 decimal place in cm, so we put all 1 decimal place for our reading: 30.0, 20.0, 16.7, 15.0, 14.0. So for the secondary data mean the data is gained from formula or from calculator. This one you can place either 2, 3 or 4 decimal places. So normally we put 2 or 3 decimal places. So easy for us to draw, to plot a graph later on. Alright. So all my data are consistent. Okay. And students, from the table we determine from the experiment, the data is analyzed through graph. Okay, so we analyze the data through graph. In this experiment, you are asked to plot a graph of reciprocal of v, 1 over v, against reciprocal of u, 1 over u. Alright, so you just follow the data from the table and mark your point using X mark. Okay, remember when you are dealing with UAS, all point must be plotted using X. Okay, X sign. You don't plot it with a dot. Kalau nak plot data, plot dengan tanda pangkah. Jangan guna bulat-bulat. Okay, use a cross mark instead of a dot. Alright, so it is clear where you are plotting point at. And then we draw a best fit line. Okay, connecting all our data. So for this graph, it is a straight line graph. Okay, it is a straight line graph, and make sure your graph touch the y-intercept and the x-intercept here. Don't let it hanging, students. Very important, right? Okay, and from our graph plotted, we determine the gradient. So how to determine gradient? You can take any 2 points along the line. It does not necessary the point from the table. Okay, you can take any 2 point which you easily read from this line. And normally we show a gradient from the 2 points we are taking at. Alright, so for this graph, this is the point we are taken, and the gradient is negative 1.0. So this is negative gradient, and the value is negative 1.0. No unit because both axes has the same unit. Okay, so the unit has been cancelled off. So our gradient is negative 1.0. Alright. So now students, how to determine focal length from this graph? So from this formula, thin lens formula, 1 over u plus 1 over v equal 1 over f. And this is an equation for a straight line. Okay, y equal mx plus c. Okay, how to relate these two formula, students? From our graph, our y-axis is 1 over v. Okay, our y-axis is the reciprocal of v. So this thin lens formula, we can rearrange, make 1 over v as the subject, which means 1 over u, we bring it to the opposite side. So it become 1 over v equal 1 over u plus 1 over x. So now our 1 over v is actually our y-axis. Okay, our y is 1 over v, reciprocal of v. So x-axis is our reciprocal of u. 1 over u is our x-axis here. Okay, which means 1 over f is our y intercept. So here is 1 over f, our intercept. Is magnified for you. So here is our y-intercept equal to 1 over f. So 1 over f equal to 0.10. Alright. Okay, and the gradient, the gradient is m. So this is our equation. 1 over v equal to negative 1 over u plus 1 over f. Alright. So how to find the focal length? So the focal length is here. Okay, the intercept, the y-intercept of the graph, which is 0.10. So which means our focal length is 10 centimeter. All right. So I hope you're clear how to determine the focal length from this graph of experiment relating object distance to image distance. Okay, so the focal length can be determined from the reciprocal of the y-intercept of the graph. So if you're clear with me, you can type number 2 in the live chat. All right. Okay. So we conclude the focal length of the lens is 10 centimeter. Okay. Okay, so student, what is the conclusion we can make? Okay, JTZY, thank you very much for your response. All right. Okay, so for the conclusion, the graph of 1 over V against 1 over U shows that 1 over V decreases linearly. Okay, this is another example of question can be asked in UAS, Ujian Amali Science. What is the relationship, okay, of y and x from the graph plotted? So here we learn, remember earlier before in 1.2 scientific investigation. So 1 over v decreases linearly with 1 over 2. We also have Adib Kalish there. Okay, thank you very much for your response, Adib. So by this object distance, u increases, image distance decreases. So the hypothesis is accepted. Okay. Okay, student. So that is the first experiment. So what is the safety precaution we can write for this experiment? Okay, so first, Waalaikumsalam, Cikgu syukur. Terima kasih join kelas saya pada malam ini. Okay, Alhamdulillah, mudah-mudahan membantulah anak-anak kita mengulang kaji untuk tajuk thin lens formula ini. Alright, students. So for the safety precaution, first, since you are taking reading, so we say eye position. Okay, eye position must be perpendicular to the scale of meter rule. Here you must mention what apparatus you are using. Okay, eye position must be perpendicular to the scale of meter rule when taking reading to avoid parallax error. If you are doing experiment involving heat, okay, so you are taking the temperature using thermometer. So you can write eye position perpendicular to the scale of thermometer, okay, to avoid parallax error. Okay, when you are using stopwatch, okay, to take reading for free fall experiment or inertia example. So you can say eye position perpendicular to the scale of stopwatch or to the needle of the stopwatch to avoid parallax error. Okay, another one for this experiment, since it is involved lenses, so it must be conducted in a dark room, okay, in a dark condition. So experiment should be carried out in a dark room condition. So this is special safety precaution for experiment involving lenses. Okay, another thing you can say, experiment is repeated for 3 times and the average reading is calculated. Alright? Okay. So that is the first experiment. So now let us take a look at this example. Okay, I hope you can answer with me the first question. It is very simple. We have a diagram there. Okay, it shows a ray diagram for an image. So this is our image. Okay, formed by an object placed at a distance of 15 centimeter in front of a convex lens. So this is our object on the left. It is placed 15 centimeter from the convex lens. So first question, name the light phenomenon involved, student. Namakan fenomena cahaya yang terlibat dalam kanta. Yes. So what is the light phenomenon involved in lenses? So if you know the answer, show it in the live chat. Alright. Okay. Ya, bagus. So jawapan dia, yes, the light phenomenon is refraction. Ya, refraction of light, pembiasan cahaya. Alright? Okay. Second. Okay, now calculate, find the focal length of the lens. So this is the first exercise, first question for you to apply the thin lens formula. 1 over u equal 1 over v plus 1 over u plus 1 over v equal 1 over f. Okay, find the focal length. You are given object distance here 15 cm and the distance between the object and the image is given 75 cm. So from here we can find our image distance. Okay, so what is the focal length, students? Okay, I give you 30 seconds to find the focal length. It is a simple calculation. Just apply the formula, substitution, answer with unit. Okay, Joris. Okay. Welcome, Joris. Thank you for joining me even though your exam is readily finished. Okay, I really appreciate your effort. Okay, and support. 12 centimeter, Joris said. Okay, so let us check, correct or not. So this is our object distance, 15 centimeter. Our image distance is 60 centimeter. Okay, JTZY 12.5. Okay, where is that 0.5 coming from? JTZY, can you calculate again? Okay, so answer 1 over f equal to 1 over 15 plus 1 over 60. So 1 over f equal to 12. So the f focal point is, focal length is 12 centimeter. Okay, 12 centimeter. Okay, JTZY, are you clear now? So Joris, congrats, your answer is correct. Okay, JTZY, you can recheck your calculation. Alright. Okay, now find the height of the image. If the height of the object is 1.2 cm, students. Find the height of the image if the height of the object is 1.2 cm. So if you remember in 6.3 before, when we learned about image formation by lenses, we learn one formula for linear magnification. Okay, linear magnification for lens. M is equal to height of image divide height of object. Alright, okay, so JTZY says 6 centimeter. What is 6 centimeter? Is it the height of image? How do you get 6 centimeter? Okay, check back your answer. So this is the formula for magnification. Okay, magnification is equal to height of object divide, height of image divide height of object, and also equal to image distance divide by object distance. So we have HI, we are looking at height of image. Our height of object is 1.2. Our object distance is 15 and our image distance we determine here is 60. So when you solve for this, the height of image is 4.5 centimeter. Okay. JTZY, again for question 2, you may check where did you mistake at. Alright. Okay. So student, for your reminder, the formula for magnification is not given in the formula list. Okay, so you must put it in here in your brain. Formula for linear magnification is not given in the formula list in paper 1 and paper 2. M equal to HI divide HO is not given. M equal V divide U also is not given. Okay, so because it is a derivation formula not given in the formula list. So you must memorize the formula. Alright. Okay, next. Okay, now predict. You have to predict what happened to the image form when the object is moved closer to the lens until it is at a distance equal to the focal length of the lens. Okay, now from the previous question, the size of the image is greater than the size of object, right? So now we move the object closer to the lens. Okay, so what happened to the size as image when now the object is exactly at the focal length of the lens, as shown in this diagram? Okay. So what is the focal length? Just now we calculate the focal length is 12. So initially the object is at the distance of 15 cm. Now we move it to the front until it is 12 centimeter from the lens, equal to its focal length. So from this drawing, what happened to the image form, student? So here it will form a real, okay, image, okay. Okay, the image form is real, okay, magnified, and the distance of image increases further from the lenses. So now when it is exactly at U, the image is virtual, upright, magnified, and form at infinity. So this is the final characteristic of image when we bring U exactly at the focal point, okay, at the focal length. So here you can see these two lines is parallel. So where is the image formed at? The image is formed up here, okay, at infinity. We don't know the exact distance, and it is somehow virtual. Why virtual? Because it is formed at the same side of the object and it is upright. Upright means it is formed above the principal axis as where the object is at. So the image is virtual, upright, and magnified when U is exactly at F. Alright? Okay. Okay, now our second learning standard. So we have done with the first one to study what is the relationship between U and V and how to determine focal length of thin lenses using thin lens formula. Okay, now second problem, second learning standard. Let's solve a formula. Let's solve a problem using thin lens formula for both convex and concave lenses. Okay. Before that, let us take a look at this table. Student, it is very important for you to understand the sign convention used in thin lens formula. Okay. So if you look at this table, this is thin lens formula. 1 over F equal to 1 over U plus 1 over V. Alright. Okay. So students, for the focal length, okay, the focal length, for convex lens, okay, convex lens has a positive focal length. It has a real focal length, so the value is positive. While for concave lens has a virtual focal length, so it has a negative value. So when you apply this formula, when the lens is concave lens, you must put negative at F for concave lens. Alright. And for the image distance, later when you calculate V, let's say they ask you to find the image distance. Okay. Later, if you find V is positive value, okay, V positive value, it means that it formed a real image. Okay, V positive value mean the lens form real image. Mean the image is at the opposite side of the object. Alright, but when you calculate and then you find V has negative value, so what does it mean? It means the image form is a virtual image, which means it is formed at the same side as the object. Okay, so you have to understand this positive and sign convention for focal length and image distance. Okay, so I repeat, for convex lens, it has positive focal length. For concave lens, it has negative focal length. Okay, while for V, if you get the value positive, so it means the object, the image form is real. And when you find from your calculation, V has negative value, it means the image is virtual image. Alright, okay, we try on the next exercises later on. Okay, before that, if you look at this GIF, this says the diagram show image formation for convex lens and concave lens. Okay, on the right, this says the image form for convex lens when you place the image at the different position. Okay, you can see the characteristic of image varies, depend on the object distance. Okay, depend on the position of object. While for concave lens, The characteristic of image is always the same regardless of where we place the object at. Okay? Position and characteristic of image always virtual, upright, and diminish regardless of the position of object. Alright? Okay. Okay, now let us try your understanding. Let us try this question together. Okay, so for question number 1, this is the diagram you are given. Okay, we have an object. This is our object. A box is placed 30 centimeter from a convex lens. So we understand what is this 30 cm? This is, yes, this is object distance. Okay, and this focal length, this lens has a focal length of 20 centimeter. So we have two information there. U, object distance, 30 cm, focal length, 20 cm. So since this is convex lens, so F is positive 20 cm. Okay, now how far from the lens is the image? So this question is actually asking for image distance, V. Find V. Okay, student, find V in question 1A. I give you 1 minute to try this. U is 30 cm. We have F 20 cm. So find what is V. Okay, if you're done, again, you can share your answer in the live chat. This is a very direct question. Just apply the formula for thin lens and substitution. Answer with unit. Okay. Who else with us other than Joris, JTZY? I guess earlier we have Chia Ying there. Are you still there, Chia Ying? Chia Yao? Okay. Okay. Very good. Okay, so this is our information given. U is 30, F is 20 cm. So this is our formula. So 1 over 20 equal 1 over 30 plus 1 over V. So our V here is positive 60 cm. We get positive value. Okay, so positive value mean our image is real. Okay, so the image is located 60 centimeter from the optical center of the lens on the opposite side of the object, which means it is a real image. All right. Okay, next question 2, student. Now find the magnification produced by the lens. Magnification produced by the lens. If you look at this diagram, the size of image is larger compared to the object, right? Mean the image has been magnified. So magnification mean how many times this image has been magnified. All right. Okay, how to find magnification? Remember, magnification M equal to HI divide HO, height of image divide height of object. It can also be M equal image distance divide object distance, V divide U. Okay. Okay, siapa dapat jawapan boleh kongsi. If you are done with your calculation, don't be shy, share your answer in the live chat. Okay, as we are learning, if you get it wrong, so I am here to correct you, students. Okay, JTZY -2. Okay, let us take a look. Okay, are you responding for question B, -2? How to find magnification? Okay, magnification. So magnification, V is 60 and U is 30. Okay, so answer is 2. Okay, answer is 2. So when you get M greater than 2, student, what does it mean? When M greater than 2, so we understand the image has been magnified. Okay, M is, where is the -2 coming from? JTZY, V is positive, U also positive. So we have 2 students. Okay, another thing, when you calculating for M, actually you can ignore the negative sign because the negative sign here, it only define either the image is virtual or real. Okay, so here for magnification, it is okay if you didn't put the negative sign. But for this question, both U and V earlier is positive. So answer M equal to 2, which means image is magnified. Alright. So student, remember when you are calculating magnification, if you get M less than 1, okay, 0.8, 0.12, so we understand the image is diminished, means smaller than object. And when you calculate M is equal to 1, so what does it mean? It means that the object and the image has a same size. So here as M is greater than 1, which is 2, so we understand image is magnified. Okay, now can you write the full characteristic of the image, student? So from M, we understand image is magnified. From B, when you calculate V, V has positive value. So we understand the image is real. Okay, and now from this diagram, we can see obviously the image is inverted. Okay, so answer, yes, very good. Virtual, how to be virtual? It is real. Virtual upright magnified, where you get it from? Okay, look at this diagram. It is real, inverted, and magnified. Okay, this is our object. This is our image. So the image is real. How we know real? From calculation V, the value is positive. So image is real. It is magnified from this calculation of M greater than 1. And from this diagram, it is obviously clearly that the image is inverted. So answer real, inverted, and magnified. Okay, Adib, you can correct your answer. Yeah. Okay, I hope you get the concept now. Okay, next student. Never mind, we try next question. Okay, we try number 2. Okay, number 2. Okay, now we have concave lens, student. Concave lens. Okay, concave lens. Remember, concave lens has a negative F. Okay, concave lens has a negative F. Okay, so this is the information we are given. Object is placed 30 centimeter from a concave lens with a focal length of 20 cm. So we have two information there. Object distance 30 cm, U 30 cm, F negative 20. Okay, F negative 20. So the first question, how far from the lens is the image? How far from the lens is the image? Alright. Okay. So in this diagram, this is our object I. And when we draw the ray diagram, this is where our image form at. So the focal length is 20 cm. Don't forget to put negative on the formula because concave lens has a negative focal length. So this is our object distance, 30 cm. Okay, find image distance now, students. Find image distance now. A. Okay, find image distance U, 30 cm. F, negative 20 cm. So find V, the image distance. Okay, you can take a A4 paper, okay, and try to calculate. Okay, just take a rough paper. If you didn't print out this yet, you can take a rough paper and try to calculate. What is, Adib say 12 centimeter. Okay, what about the rest? What did you get? Okay, do you have positive or negative value, Adib? Okay, positive or negative value for V? Positive 12 or negative 12? Okay, I repeat, U is 30, F is negative 20. So you can find V, student. Okay, kita check ya, we check the answer. Okay, students, so for this question, so U 30 cm, F negative 20 cm. For the positive value, it is okay if you didn't put negative, but negative you must place. Okay, so we replace, we substitute in this formula. So 1 over F, put negative there. Negative 1 over 20. Okay, negative 1 over 20 equal to 1 over 30 plus 1 over V. So this is simple mathematics, plus minus and divide. So we make V as the subject. Okay, make V as the subject mean we bring 1 over 3 to the other side. So now it become 1 over 20 minus 1 over 30. So our V is negative 12 cm. So remember V negative showing us the image is virtual, student. Negative sign for V showing image is virtual, means form at the same side as the object. Okay, so the image is 12 centimeter. This is our image distance, 12 centimeter. Then the negative sign shows that it is virtual image. Okay, now we can write the characteristic of image for concave lens. Okay, so what are they? Before that, we answer B first. Okay, we'll answer B first. What is the magnification for this lens, student? Again, find M. Okay, find M first before you write the characteristic of image. Okay, find M. How to find M? V divide U. Okay, M equal to V divide U. Okay, image distance divide object distance. Okay, so for this, V is 12 and U is 30 cm. So answer is 0.4. Okay, Joris, for magnification, you can avoid the negative value, okay, for magnification. So you will get 0.4. So it is less than 1. So we understand our image is diminished as shown in this diagram. Okay, so we now can write the characteristic of image produced. It is virtual, upright, and diminished. Virtual is determined from this calculation. V negative show virtual image. Diminish we determine from the calculation of M less than 1. Show image is diminished and it is upright. Okay, remember for concave lens, the characteristic of image always virtual, always upright, always diminished. Okay. Okay, so let us now try the third question. Okay, cuba pula soalan yang ketiga. Okay, third question, everyone. Okay, now we have concave lens. Okay, concave lens. So remember, concave lens has negative focal length. Okay. So focal length 25 cm. So in a formula, you must put negative 25. Okay. It forms a virtual image. So it mentioned here, form virtual image of an ant at a distance of 20 cm from the optical center, which means in the formula, V must be negative 20. Okay, V must be negative 20 because it's a virtual image. Okay, now find the original position of the ant, which means we must find the object distance. Okay, find the object distance U. Okay, so this is our given information. V negative 20 and F negative 25. So in a formula, must put F negative 25, must put V negative 20. Okay, find your U, students. Okay, find U, object distance. Okay, so from this calculation, it's already shown. So 1 over F is 1 over negative 25 equal to 1 over U. We are looking for this. So plus sini negative 1 over 20. So answer is 100 centimeter, positive 100 centimeter. So the object is at 100 centimeter in front of the lens. Okay, object distance 100 centimeter. Okay, now they ask us to draw the ray diagram. Draw the ray diagram to show the formation of virtual image of the end. So how to draw? First, you draw a concave lens. So this is the symbol for concave lens. Okay, you can draw also the exact concave lens. So our F is 25, so this is F25 here. Okay, you can measure using a ruler, okay, 25 cm, and then or you can use a graph. Okay, here F25 cm, and our object distance is 100 cm, so you can mark this is our object distance 100 cm. Okay, so we draw the ray diagram. Remember, there are 3 rules you can apply in drawing the ray diagram. So first, we draw a straight line from the object parallel to the optical center. Don't forget the arrow. So what happened? This ray will be diverged. Okay. It will be diverged from the focal point at the front. Okay, it will be diverged from the focal point at the front. Second, you draw a straight line from the object to the optical center. So this line will be continue travel in a straight line, not refracted. Okay, so this is the intersecting point between these 2 lines where our image form at. Then you can mark the image distance is a 20 centimeter. Okay, in front of the lens. Okay, this is how to draw the ray diagram for question 3. When we have all the information, we have F 25 cm here, U is 100 cm, and V image distance 20 cm. Okay. Okay, students, so this is our next question. So I hope you are doing great so far. Okay, we try question 4. All right. Okay, question 4. This is the diagram. Okay, this is the diagram. It shows a convex lens. We place an object in front of a convex lens at a distance of 9 centimeter as shown in this diagram. If I magnify it for you, okay, our object is at a distance of 9 cm from the convex lens. Okay, and this is another information. The focal length of the lens is 6 cm. So since this is convex, so the focal length is positive 6 cm. And given the height of the object is 2 cm. Okay, so this object has a height of 2 cm. So first, find image distance, student. So this is where our image form at. Find its distance. Okay, where to find image distance? If you draw where is image distance measure from the optical center to where the image is at. So this is our image distance, V. We want to find it. Okay, how to find V? Sorry. Okay, how to find V? Okay, find your V now. This is very direct question. Just substitute. In the formula, F is 6 and U is 9 centimeter from this diagram. So we can find V. So what is V? If you're done, you can share your answer. Okay. Do we have an answer there? Not there? Not yet. Still waiting. Okay, we have an answer there. Okay, let's see either correct or not. Okay, so this is our information. U is 9 centimeter. Okay, from diagram. And F is 6 centimeter. This is convex lens, so F positive. So 1 over F is 1 over 6 plus 1 over U, which is 1 over 9 plus 1 over V. All right, so we solve for 1 over V. it is 1/18. Okay, so here our V has positive value 18 centimeter. So we understand the image is real. Okay, image is real, formed at the opposite side of the object as shown in this diagram. So now we know V is 18 centimeter. Okay. Okay, now find the height of the image. What is the height of the image if given the height of the object is 2 cm? Okay, height of object 2 cm. It's hard to find height of image. So you can use the magnification where m equal to hi divide ho equal to v divide u. Okay, so since we don't have m here, so we can relate hi divide ho equal to v divide u. Okay, you can use this formula. So you want to find height of image, hi. So height of object is 2 cm given in the question. Image distance is 18 and object distance is 9 centimeter. So by this, our height of image is 4 cm. Okay, is 4 cm. So the image is inverted, real, and magnified. Okay, inverted, real, and magnified. Okay. Okay, now the fifth question. Okay, I hope you're doing good so far. There, let us take a look at question 5. Okay, this is objective question. We have 4 answer there. A 1/f, B 1/u, C F, D U/v. Okay, they ask you to find the value of Q. What is Q here? Okay, shown in this diagram B. Before that, diagram A shows apparatus used to determine relationship between object distance and image distance V and the focal length of a convex lens. So this is the experiment we did, okay, earlier in this lesson. So the result is shown in diagram B. So this is the graph plotted for 1/v against 1/u, a graph of reciprocal of V against reciprocal of U. So we have 2 points there, 0Q and then P0. Okay, 0Q is the point here and here the point is P0. Okay, the question is, what is the value of Q, student? Okay, what is the value of Q? So if you understand, okay, this point is the y-intercept. Y-intercept is the reciprocal of f. Okay, the y-intercept is the reciprocal of f. Y-intercept is 1/f. Okay, so which mean Q is 1/f. So answer is A. Okay, point here is 0.0, then the Q is 1/f. Alright, okay, simple. Okay, next. Okay, question 6. Okay, question 6. I think this is our last question for today. Okay, we have figure 6.1. It shows an image of letter Fizi, F-I-Z-I. Okay, when viewed through a glass of water. The K has been missing. Okay, this is the original, okay, the object. This is the image when we look through it from a glass of water. Okay, you can see the image has been enlarged. All right, so the K is missing. Okay, state the light phenomenon that causes the image physics to be enlarged. Okay, student, again, what is the light phenomenon involving here? So the phenomenon is, yes, it is refraction. Refraction of light. So the water in the glass is act as a lens. So the phenomenon is refraction of light. Okay. Okay, next. What is the change of size of image if the water is replaced with a transparent liquid of a greater optical density, students? So what do you think happened to the change of size of the image if now the water is replaced with a transparent liquid of a greater optical density? So, is the size increases or decreases? That is the change. Increased, decreased, or no changes. So what happened when the liquid has a greater optical density compared to water? So answer, yes, answer, the image will be increases because the effect of refraction will be greater for higher optical density liquid. Okay, so size of image increases, or you can just say increases. All right, okay, next. Okay, now, okay, question C. So here we are given a few information. The glass of water is replaced with lens M. Now we change. We replace the glass of water with lens M. All right. Lens M has a focal length of 10 cm. Okay. The distance between the book cover and the optical center of the lens is 8 cm. So this is our object distance, 8 cm. Okay. And it is observed that the image physics is enlarged. All right. Okay. So first, name type of lens M. Okay, student, what type of lens M is? Is it convex lens or is it concave lens? Which one? Okay. The keyword is here. The image is enlarged. So which lens enlarge the image of enlarge the size of the image? Okay, remember, concave lens image always diminish. So it couldn't be concave lens. So this must be convex lens. Okay, so our convex lens here is act as a magnifying lens. Okay, now second, find the image distance. Question 2. Calculate the distance of the image from lens M. Okay, so again we apply thin lens formula. Okay, we have F is 10 centimeter. We have U, 8 centimeter. So we can find V. Okay, find V, students. If you still there with me, can you try find V? When you are given F, 10 cm, and U, 8 cm. Okay, find V for lens M. Okay. Find V for lens M. Yeah, so answer. Okay, very good. So the formula is 1 over F equal 1 over U plus 1 over V. So we have 1 over 10 equal to 1 over 8 plus 1 over V. So find V, students. Okay, so answer. Yes, so answer is V, negative 40 cm. Yes, now you get it right, JTZY. Okay, so I guess you understood now. So what is negative sign means? Is our image virtual or real? What is negative sign mean? Our image virtual or real? Okay, V is negative 40 cm. Okay, the negative sign shows that our image is virtual or real image, student. Yes, very good. So our image is virtual. So for magnifying glass, our image is virtual, upright, and magnified. Very good, JTZY, or whatever your name is. Can you introduce your full name? Okay. Okay, finally. Okay, C3. Find the linear magnification of the image. Okay, student determine, find linear magnification of image. Okay. You remember magnification? Magnification we can determine from two formula. M equal HI divide HO, height of image divide height of object. M also can be determined from distance of image V divide distance of object. Adib say, what is this -5 refers to order magnification. Okay, so for magnification, okay, remember for magnification, you can avoid the negative sign, okay, because magnification is a ratio of height of image to the height of object, ratio of image distance to object distance. So for calculating ratio, we can ignore the negative sign, okay, so we'll have 5, okay, so M5. So we understand the image has been magnified 5 times, okay, from the original size. Image telah dibesarkan 5 kali daripada saiz objek yang asal. Alright, okay, so by this we understand the image form is virtual and magnified. Okay, virtual and magnified, and somehow it is upright. Okay. Okay, so I guess that's all for tonight, students. Saya rasa itu saja masa yang kita ada pada malam ini. Tajuk ni tak susah sebenarnya. Ada 2 learning standard saja. We only have 2 learning standard. First one, how to relate U and V. So we understand when U increases, V decreases. And then how to determine focal length for convex lens using thin lens formula. So if you draw a graph of 1 over V against 1 over U, the focal length can be determined from the intercept, from the y-intercept of the graph. Okay, so itu saja masa yang kita ada pada malam ini. Cikgu harap apa yang cikgu kongsikan sedikit sebanyak dapat memberi anda kefahaman yang lebih. Kalau yang sudah faham tu, harapnya bila join kelas ni lebih faham lagi macam mana nak tentukan jarak image, macam mana nak kira panjang fokus, jarak objek, how to determine U, V and F using the thin lens formula. Okay, dah alhamdulillah, mudah-mudahan memberi manfaat kepada semua yang mengikuti kelas pada malam ini. Okay, jadi jangan keluar lagi, cikgu kongsikan dahulu pautan untuk e-sijil express. Anda boleh isi, boleh simpanlah sebagai kenang-kenangan sempena anda mengikuti kelas Cikgu Hasnitah. Okay, so jangan lupa bersama saya lagi pada minggu hadapan, insya-Allah. Next week I will be back with 6.5 optical instrument. Okay, optical instrument 6.5, same time, same day, Sunday 8:15 PM. And for next week, you also have another slot. Kita ada satu lagi slot pada minggu hadapan, iaitu pada hari Jumaat 9.30 malam akan disampaikan oleh Cikgu Rosemawati. Yang ini khusus untuk calon SPM, pecutan akhir SPM siri yang kedua. Siapa yang terlepas pecutan akhir siri yang pertama bersama Teacher Slinda Nordin, anda boleh pergi ke channel Teacher Slinda Nordin atau pergilah ke www.akademiyoutuber.com. Boleh tonton semula siarannya di sana. So, terima kasih atas masa dan usaha. Mudah-mudahan Allah membalas usaha anak-anak sekalian dengan kejayaan yang gemilang. Jadi itu doa cikgu. Jaga diri, jaga kesihatan. InsyaAllah kita jumpa lagi dalam siri-siri yang akan datang. Assalamualaikum, selamat malam dan selamat berehat semua. Okay, jumpa lagi. Bye-bye.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rakan laksana dengan jitu, penuh bervisi guru AYU, mencapai misi yang satu. Pervisi kita bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini. Lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rakan laksana dengan jitu, penuh bervisi guru AYU, mencapai misi yang satu. Pervisi kita bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha AYU capai kecemerlangan, berpadu AYU cipta kegemilangan, bersatu AYU bina wadah terbilang, terus berjaya bersama AYU.
Berusaha AYU capai kecemerlangan, berpadu AYU cipta kegemilangan, bersatu AYU bina wadah terbilang, terus berjaya bersama AYU.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rakan laksana dengan jitu, penuh bervisi guru AYU, mencapai misi yang satu. Pervisi kita bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.